the moment because
Yeah.
I know Mary is absolutely busting to tell us about noctilucent clouds. Isn't that right, Mary?
Yes, absolutely. Yeah, they're probably one of my favorite things to see. And I always say, if you're not sure whether you've seen them or not, you probably haven't, because you know. I'm just going to share my screen because there's a few things I want to tell you about them. First of all, noctilucent means night shining. So it literally translates as night shining clouds. And that's what they do. They look like they're shining out through the twilight sky. And they're a kind of polar mesospheric cloud, which means they're right up on the edge of space and they accumulate around the poles. They're only visible during the summer months. So for us in the Northern Hemisphere, that's right now. The season has kicked off. If you are in the Southern Hemisphere, it will be during your summer months. And they only become visible in deep twilight. So it's like about an hour after the sun has set, or 90 minutes after the sun sets, and before the sun rises. So once we get into the middle of June, basically they can be visible all night long. So they're incredibly antisocial. They mean I spend most of my summer extremely sleep deprived because I sit up all night looking for these things. But they're really interesting because they were never recorded before 1885, and they are on the rise. So the strong theory is that it's connected to global warming, and I'll explain why in a second. So first of all, just to give you some context, when we talk about mesospheric clouds, cirrus clouds are the highest clouds we have in our troposphere, excluding supercell thunderclouds that go higher. And these clouds, cirrus clouds, are what give us ice halos and sundogs and stuff like that. But noctilucent clouds are right up on the border between the mesosphere and thermosphere, which is basically the edge of space. So they're only kind of 20 kilometers below the bottom edge of aurora. So they're really, really high. But they accumulate around the North Pole. So you would think, how can we see them from anywhere other than the North Pole? And it's because of how high they are. So even from kind of most of the UK, actually, and sometimes if you're really lucky down into mainland Europe, if you look to the north in twilight, you will see these clouds, hopefully. So the reason they're not visible during the day is down to ice crystal size. And this is mind-blowing. So the ice crystals, the hexagonal ice crystals that give us ice halos, are 0.1 millimeters in size. So this this blue box with the black edge here is 0.1 millimeters. So that's small. The size of a noctilucent cloud ice crystal is that dot there relative to that. So it hits 0.1 microns across. So they're really, really tiny. So when they reflect sunlight back down, you don't see them in daytime because there's too much light in the lower levels of the atmosphere. Now, the way that they form is also very interesting and still stuff we don't fully understand, but you need a source of water, first of all, and the mesosphere is very dry. And the reason for that is that UV from the sun breaks down water. And that means that when we have more solar activity, there tends to be less likelihood that there'll be water there in order for the crystals to form. But you also need a nucleus at the center of that crystal, which is micrometeorite dust. And like we're talking so small that it would be right at the center and even smaller than that 0.1 micron thing that we're looking at here. So there were some theories about volcanic dust because about 3 or 4 years before they were first reported, there was a massive eruption in Mount Krakatoa, which sent a lot of volcanic ash up into the upper atmosphere. It could be that, but I think generally the consensus is that it's micrometeorite dust. So they're really, really beautiful, and they are visible usually kind of between, I'm trying to remember off the top of my head which latitude it is. I thought it was on the slide, but it's not. It's 45 to 60 degrees. So between 45 and 60 degrees latitude is where you're likely to see these. If you're any further north, it doesn't get dark enough because the sun has to be between 6 and 16 degrees below the horizon. When it's there, the lower levels of atmosphere are completely in shadow, but these clouds are so high that they're still getting sunlight, which is why they have this glowing quality about them. So you tend to see them if you are further north than than that kind of range, it doesn't get dark enough. So if you are actually at the North Pole, you're not going to see these clouds, even though they're essentially above your head. Now, they can actually extend over a huge amount of your horizon. I've seen them 120 degrees of horizon with noctilucent clouds on them. After sunset, they tend to be more in the northwest, because obviously that's the side of the sky that the sun is on. But sometimes you can get bits of, like the kind of panoramic picture here, you can get bits of cloud anywhere along the horizon there. Sometimes you get it across the whole horizon, and other times, like before dawn, it tends to be more towards the east. And I always see better noctilucent cloud displays in the east before sunrise. They're always better than the after sunset ones. I don't know why that is. So they have lots of different sorts of structure, and no two displays are ever really exactly the same, but you can see they have this bluish white color mostly, but you can get red ones as well. This bottom picture here was taken a couple of years ago with Comet Neowise in shot as well, just absolutely beautiful. They can resemble ripples, they look like water waves, they're just unbelievably beautiful. And I believe this was the remains of a noctilucent cloud tornado, which is quite an awesome thing as well. So if you are a little bit further north in the UK, you will see these a little bit higher, but they're generally quite low in the northern horizon. The further south you are, the lower to the horizon the clouds will be. And obviously, unless you get a really brilliant display that goes up beyond the zenith from the UK, you may see them in mainland Europe as well. So yeah, they're very, very beautiful, very mysterious, and they make the most incredible time-lapse subject. I had to include this picture taken by my friend Stephen Cheatley, because what doesn't make any picture better than having a roller coaster in the foreground? But this is such a beautiful display, and you can see that because he's in Blackpool, he's got that much more of the sky filled with noctilucent clouds. I've got a little time lapse to just show you here. They move in a very different way from tropospheric clouds. They're just gorgeous. I mean, I can't emphasize enough how beautiful they are. My husband just rolls his eyes because I'm obsessed with these things. And, you know, I'm happily going to set my alarm for 1:30 in the morning to get up to try to look for them. But I've got a close-up bit of this video here to just show you what they look like up close. And they are really, really pretty. So if you do get an opportunity to photograph them, just keep your camera in one place and keep taking photos, because getting a time lapse like this is just gorgeous. Now, there's one thing that can help you with your observations. If you set an alarm for 1:30, before you get out of bed and look out of the window, go to the Noctilucent Cloud webcam pages, and the links to both of those sites are in the description box, hopefully. And basically, the parts of Europe that are an hour ahead of us, you will see on the webcams pointing north whether there are any noctilucent clouds visible. If there are, then it's worth getting out of bed. If there's nothing showing on the webcams, then I just go back to sleep now. I used to just go and camp out in a field for the whole night just in case, but, you know, I kind of value my sleep a little bit more these days. So you can see they are really pretty. They're just really mesmerizing to watch. They look incredible through binoculars. One thing that will help you as well is on Twitter, there is an account called NLC Alerts and one called NLC Net. Both of those will post if people are actively seeing displays, and people within the community of observers will hashtag NLC Now. So you can go to Twitter or other social media platforms and just see if other people are reporting the clouds, because if they are, there'll be a good chance that you'll get them too. And don't forget, like with all astronomy, submit your observations to the BAA, because these are a type of thing that are still relatively new in terms of how frequently they've been seen, because most weather events have been reported since the kind of, well, dawn of time essentially, but noctilucent clouds haven't been around that long. So we need more information on them and kind of gauge how they're forming, how they're evolving, and how they link with solar activity, because the more active the sun is, the more UV there'll be, the more water gets broken down and such like. So we need to kind of submit our findings on this and help people learn more about them. So good luck looking for them. Yeah, I turn into Gollum during the summer because I'm not asleep very much, but they're worth it.
They certainly are, Mary. Thank you so much for that. All of Mary's links and information you will find in the description of this video. Look underneath that and it's all there. I've got Noctilucent clouds and aurorae on the bucket list of things that I want to see before I die. I've never seen either, and living here, I'm not likely to see either. So there we are. I'm far too far south. But you never know. You said that it's possible. It's possible I may see Noctilucent clouds, but it would have to be a damn good showing of them. Okay,
Mary,
thanks for that, Mary.
Sorry, just a quick question. Mary, you say they happen in the northern hemisphere. Do they happen in the southern hemisphere as well?
They do, yeah. They're not reported as frequently, mostly because there just isn't as much habitated landmass in the southern hemisphere. They tend to have quite weird seasons down there, but they do form around the South Pole. And there is a satellite, that picture I showed you of the daisy, that is actual satellite pictures that show the accumulation. And there's one that covers the south during their summer months. So it's only really in the UK from mid-May through to mid-August is our season. There is also a link to an in-depth article on NLCs on my own website, which I think is in the description, and that will tell you the period of time that it's visible in the southern hemisphere.
Okay, thank you for that.
Right. I have a question as well. Mary, thanks so much. I'm really excited, actually. I don't think I've ever seen a Noctilucent cloud before. Could you recommend the best time to view them? Obviously, in summer, you were mentioning 1:30 in the morning. Like, that's really late at night.
Yeah, it has to be when the sun gets less than 6 degrees below the horizon. So from about an hour after sunset or an hour before sunrise. So in midsummer, that is incredibly antisocial. You just don't go to bed because they can stay visible all night long. But at either end of the season, you're more likely to get one that's a bit closer to dawn and still have time for some sleep. But yeah, you need to be out really at those times because that's when the sun's low enough that the lower level is in atmosphere, but the clouds are high enough to still get the light. So yeah, they are really antisocial. I'm quite grumpy most of the summer because I don't get enough sleep.
Great, thanks for that. And